Hey guys, Dave and Todd here, and a lot of people assume that all electric heat is created equal, and that's not the case. Today we're going to be looking at this space heater here, and you see the amp clamp. We're going to look at the amount of power coming to power this, amount of energy going to power it, and the amount of energy through this amp clamp here to power this inverter compressor mini split with a condenser up on the and compressor up on the roof there, okay? So, Todd, without further ado, you can, we'll see up on your rooftop office here in a second. And so let's start out talking about this unit right here. A lot of people have these in their basements, guest rooms. Wonderful in their simplicity. They take 1 watt of power in, they burn that watt in this resistive heat element, so it's 1 for 1. 1 watt in gives you 1 watt out. And they're pretty much very consistently, these things are rated at 1500 watts. Why 1500 watts? Well, that way you can plug them into a standard 15 amp breaker. All right, they stay under the 15 amps. So this one right now is nicely running at 12 amps. So 12 amps times 120 volts gives you around 1500 watts. So what does that mean in terms of BTUs? Well, to get to BTUs, you take this, you take the 1500 watts here and you multiply that by 3.41. So watts times 3.41 gives BTUs. Okay, so this one's at 12 amps. And this, we can look at what this one's, the mini split's doing here too. Okay, that one right now, that's running at only 499 watts. Why? It reached the set point. So let's try and turn it up a little bit. And you'll see the watts go up slightly, probably here. But they're going to be probably peak for right now at around 700 or 800 watts. And that's because it's the last real day of winter here. So in the morning it's 55 degrees here in Las Vegas. So as you're closer to 75 degrees, less distance with heat pumps, they take less power. This one seems pretty satisfied at, well, we'll see, 600-700 watts. And that can be verified, by the way, if we look at, if we multiply 120 by, can you turn that back on, Todd? Turn this, it turned off. It tries to save the battery. Can you turn it back? There you go. Pretty hard to see in the sun, but let's see from this angle. Can you tilt it a little bit? It's too sunny. There you go. Okay. 5.5 amps versus 12 amps. Okay, so what would you rather have? 12 amps for 5100 BTUs or 5.5 amps for 12,000 BTUs? And okay, you can see again, this is only, it's using that 699 watts. So as heat pumps get to a lower temperature, they can need a little bit more power. And why do heat pumps work now, and how do heat pumps work? Well, heat pumps carry energy. And so instead of like this one, instead of the space heater where it's just burning power, think of it like the motors in the heat pump, the compressor up there, and the condenser fan and the fan motor in here has basically 3 fans. And those 3 fans, the 2 fans in the compressor carry the refrigerant in here. And the refrigerant, let's think about it. Think about it first in the air conditioning mode. It's kind of simpler conceptually to understand maybe. But if I come up here and it's 100 degrees in the summertime, I turn this on, that coil carries the heat out of here because the refrigerant is cold, okay? So you can imagine it's like a Costco truck pulling up. Costco is getting 5 miles a gallon, but it's carrying 1,000 or 10,000 gallons of gasoline, right? So it's carrying a lot more power than it's burning, and that's conceptually what heat pumps do. So it makes sense in the summertime that you're carrying the heat out of here, but how can it work in the wintertime when it's 20 degrees? And that was the problem before with heat pumps, is if they had just on-off compressors, they would take around, they would get down to 30 or 40 degrees only, but that doesn't work for most of the country, right? So even here in Las Vegas, if it's winter, over at nighttime, might get down to 28 degrees or whatever. But now this inverter compressor unit we have here, this will get down to 14 degrees with an inverter compressor. And now there's something called EVI, okay, evaporative vapor injection. That's what it is. New thing, EVI. It's complicated to understand a little bit, but anyway, EVI is the next way that heat pumps work, and it makes it such that you can get the heat pump, the refrigerant, much colder on the outside, and that way it can still suck up heat even when it's 35, 40 degrees below 0 Fahrenheit. So here at Airspool, we talk about air conditioning, we talk about solar, we talk about solar air conditioning. If you got anything out of this video, appreciate the like, appreciate the comments, appreciate the subscription. Thanks for your time.